Okay. Hey everyone, thank you for coming my lecture 2. Especially, you guys are really busy, I know. But thank you for coming. Okay, today, following my lecture 1, I will talk about that nuclear energy. And then,
I think they want to attend. Do you want to come in and join?
or on it.
Do you want to come in and join?
Yeah.
Okay. Yeah, sure. You can have a seat. Over there.
Oh, yeah.
More chairs.
Then change one to right there.
Oh, Kana too. Maybe we could have gone. We could have
Here,
one person should
sit
have.
here.
Yeah.
Come this way.
Okay.
And put another chair over here as well. Could somebody bring one more chair from another room?
Right. Yeah. Okay. So you can sit over there. And then you can
One can sit over there and one can sit over here beside me.
sit over there. And then you can. Yep. Sit over here.
And both of you can now come in.
I didn't just yet.
Could just be that panel as well.
Sure, I
Dennis,
think
if you can close the door.
I only prepared 6 copies of
Mhm.
handouts.
So in this case, yeah, leadership students, if you can,
They
Yeah, kindly-
they don't need it.
yeah, okay.
Oh, yeah. Actually, I did a mistake, so it's the first. Sorry. Okay. Yeah, okay. Thank you for coming. Oh yeah, suddenly it's really crowded. Yeah, following my lecture 1, I will talk about. Bye. I will talk about nuclear energy for an hour. So, actually, is there anyone who took lecture 1? Only one. Yeah? Only Joe, Sue, and Edwin? Oh. Yeah, it's okay, it's okay. First of all, I will review what we learned in lecture 1. Yeah, you took it. Yes. In lecture 1, I talked about some scientific knowledge of nuclear energy. Firstly, nuclear chain reaction. There are 2 kinds of nuclear chain reaction. Yeah, already.
Fission and fusion.
Yes, that's right. Fission and fusion. Briefly, yeah, I will explain it. Fission. And fusion. Those 2 are names of that nuclear reaction and atom reaction. Fission is one atom split into 2 atoms, and then as a result of the reaction, we can get a big energy. And the fusion is the opposite side, the opposite way of reaction. It means that 2 different atoms combined into 1 atom. It also makes a huge amount of energy. Okay, and then the sources of the nuclear chain reaction are uranium and plutonium. Okay. And it's this process is how that electricity is made. First of all, from nuclear reaction, fusion or fission, and then with energy, boil water. And with the heat from that boiling water, we can generate electricity. We can get electricity. And lastly, I talked about how nuclear energy, how efficient nuclear energy is. Okay, so can you remember my homework? Yeah, it's really awkward to ask that. In lecture 1, I asked students to watch one TED Talks, one TED video, and the topic was the topic was, does the world need nuclear energy? So in that video, I will briefly explain it that 2 experts talked about, do we need nuclear energy? So I edited that video.
Speaker? Yeah. You can use that speaker.
Are these speakers here?
Yeah, I can use it.
There's a USB port as well. You see that? Oh, good.
I think of most interest to the TED audience would be a new generation of reactors that are very small, down around 10 to 125 megawatts. This is one from Toshiba. Here's one the Russians are already building, floats on a barge, and that will be very interesting in the developing world. Typically, these things are put in the ground. They're referred to as nuclear batteries. They're incredibly safe, weapons proliferation proof, and the rest of it. Here's a commercial version from New Mexico called the Hyperion, and another one from Oregon called NuScale. Babcock and Wilcox, who make nuclear reactors. Here's an integral fast reactor. Thorium reactor, the nation Norvold's involved in. The governments of the world are going to have to decide that coal is need to be made expensive. These will go ahead. And here's the future.
Now 1% of world land. Matching the reliability. Baseload is actually irrelevant. We want to match the hour-by-hour power supply. You can do that by combining renewables. This is from real data in California, looking at wind data and solar data, and it considers just using existing hydro to match the hour-by-hour power demand. Here are the world wind resources. There are 5 to 10 times more wind available worldwide than we need for all the world. So then here's the final ranking, and one last slide I just want to show. This is the choice. You can either have wind or nuclear. If you use wind, you guarantee ice will last. Nuclear, the time lag and load will allow the Arctic to melt and other places to melt more. And we can guarantee a clean blue sky or an uncertain future with nuclear power.
So this video is like about 60 minutes, and then I edited it into like 2 minutes. So the first guy, the elderly guy, advocated, supported that nuclear energy. And then he said that nuclear energy is inevitable. We need it. And then other green energy sources cannot be the main energy source. And the other guy, the next guy, he said that risk is the risk. Nuclear energy is really dangerous. Even though it's efficient, we shouldn't use it. And we can make up for that much energy from other energy sources, such as solar, wind, and other green energy sources. The reason why I put that as a homework was what I'm going to talk about today is really related to that video. I've divided my lecture into 3 parts. Firstly, I will talk about safety, and then future of nuclear energy, and last part is discussion. Yeah. Interesting?
Yes.
Yes.
Thank you. Okay. Before, talking about nuclear energy. What's your image of nuclear energy? What comes to your mind?
Safety.
Safety? Are you sure?
Radiation.
Radiation and what else? Yeah, Fukushima. And usually those horrible images, radiation or horrible weapon, nuclear weapons, come to your mind. It's true. So, we will watch one more video. Can you remember the Fukushima accident?
Yeah.
It happened 2 years ago in 2011. And as you know, it was a horrible accident. And then this video was filmed in this year. Let's watch this video together.
Street views inside Japan nuclear zone. Concrete rubble litters streets lined with shuttered shops and dark windows. A collapsed roof juts from the ground. A ship sits stranded on a stretch of dirt flattened when tsunami roared across the coastline. There isn't a person in sight. Google Street View is giving the world a rare glimpse into one of Japan's eerie ghost towns, created when the March 2011 earthquake and tsunami sparked a nuclear disaster that has left the area uninhabitable. The technology pieces together digital images captured by Google's fleet of camera-equipped vehicles and allows viewers to take virtual tours of locations around the world, including faraway spots like the South Pole and fantastic landscapes like the Grand Canyon. Now it is taking people inside Japan's nuclear no-go zone to the city of Nami, whose 21,000 residents have been unable to return to life since they fled the radiation spewing from the Fukushima Daiichi nuclear power plant 2 years ago.
I didn't put that. How do you feel it? Yes, isn't it so miserable that it happened 2 years ago, and until now, many people even cannot stay there or even cannot go there to revive the city. It became like a ghost town or ghost city. Okay, let me talk about the Fukushima accident more specifically. Actually, the reason why it happened in 2011 was there was the huge tsunami, and because of the huge tsunami, there was the blackout. So in the nuclear power plant, they cannot generate any electricity and they cannot get any electricity. So they failed to control that nuclear reaction. So that nuclear power plant was out of control. And then after the tsunami, like 2 or 3 days after, the nuclear power plant was exploded. And as a result, a lot of the radioactive materials released from the nuclear power plant. So the radioactive materials released into not only the land, it contaminated the sea. And then it is spreading to other parts. The main problem is radiation. The radiation is come from that nuclear waste. Nuclear waste is from the nuclear reaction. There's a remainder, and we call that nuclear waste. And the nuclear waste includes radioactive materials, a lot of. So, it shows how radiation, how dangerous radiation is. In that table, you can see that 3 millisievert is the figure that average background exposure in 1 year. And in Fukushima, you can see that maximum dose is at 80 kilometers. It means that that accident happened here, but about this area, the radioactive figure is more than 9 millisievert. Let's go back to that table. 9 millisievert is typical yearly dose for a uranium miner. Can you imagine that? Anyone who stays in that area can be exposed by that much radiation. So how do we treat that nuclear waste? We should treat that nuclear waste really carefully. As you can see, that nuclear waste includes a lot of radioactive materials. So let's see how we treat that material. We usually bury the nuclear waste in under deep ground. Sounds really easy, just burying. Yeah, but actually it's not a easy job, because as I said, that under deep ground, let's say it's a ground, and then we have to make some space under deep ground, and then nuclear waste can contaminate other soil, other ground. Because of that, that space should be isolated with concrete. So we have to spend quite a lot of money to build it, and the most difficult thing is social problem. Is there anyone who wants to put that place in your own town or own area? Maybe nobody wants to do that. So for example, in Korea, a few years ago, Korean government tried to build that place in Wolseong, but it failed because of that. People protested against that project. So yes, as we can see, it cannot be a solution. We just hide that. But as far as we know now, we don't have enough technology or suitable way to treat that material. So what can be the ideal solution or anticipated solution? It's reprocessing technique. The reprocessing technique is being used today in some power plants. It means that by doing the reprocess, we can minimize that nuclear waste. We can minimize that radioactive materials. Can you understand? So as I said, there's a from nuclear reaction, we have remainder, a lot of remainder actually. But with the reprocessing technique, that new reactor can make nuclear waste react continuously. So we can make more electricity and then we can minimize the nuclear waste. Okay. So, and this video is included in the first video, the TED Talks video. Let's watch this. It's another risk.
Be very aware of the propaganda. Secondly, think about this. If we build all these nuclear power plants, all that waste is going to be on hundreds, if not thousands, of trucks and trains moving through this country every day. Tell me they're not going to have accidents. Tell me that those accidents aren't going to put material into the environment that is poisonous for hundreds of thousands of years. And then tell me that each and every one of those trucks and trains isn't a potential terrorist target. Thank you.
Can you imagine that? If a terrorist, like 9/11, if a terrorist targets a nuclear power plant in the USA or in, let's say, like South Korea, and then they make it explode, what happened? What could be? Yeah, what could happen?
Worse than a nuclear bomb.
Yeah.
But
Actually-
that isn't what the guy from the audience was saying.
Yeah.
He wasn't just talking to the nuclear plants. He was talking about the trucks
Yes.
carrying
Trucks.
the waste.
Yes. Yeah.
Just by blowing up one of those trucks.
Yeah. And then, yeah, the terrorists can, like,
Can't get at the
yes.
can't get at the plants because
Yes.
they're too heavily guarded.
Yeah.
But the trucks are open targets.
Yes. It's really easy to kind of capture, to be captured. So I don't really want to imagine that situation, but we have to consider that. Because only like developing the technology is not the whole thing. The whole thing. Okay. Next one is CO2 emission. Do you know what CO2 costs? Cost. Yeah. Global warming. Yes, the CO2 causes global warming. And the most of the culprits of the global warming is energy power plant, such as fossil fuels like coal, oil, or other energy power plants. So how about the CO2 emission in nuclear power plant? This graph shows the CO2 emitted by according to different energy sources. But fortunately, from nuclear power plant, the nuclear energy ranks second lowest following wind energy. So we don't have to really worry about that global warming. It's a positive thing. Yeah. So can you understand? And then do you have any questions so far? Okay. Okay, next one is, yes, more positive thing. Future nuclear energy. I put three kinds of that future nuclear energy. One is some miniature nuclear plant and 100% efficient nuclear plant and nuclear fusion. And first of all, what's a miniature nuclear plant is? Yes, that literally it's really small miniature nuclear plant. So we can put that Yeah, our house is home. And then, it sounds really weird, but it has only few waste. As a result of that reaction, we only get few waste. And then more specifically, like in that machine, there's a one capsule, and then that capsule gathers the whole waste, nuclear waste, and then we can just change that capsule in few years, every few years. And then it is invented by Hyperion company in the USA, and then they said that it can be commercialized in 2018. I think you don't like that products.
Can I ask a question?
Yes.
Okay, so if Hyperion is saying it's got a little capsule that it
Yes.
collects the waste in,
Yes.
does that mean that over time there are all these little capsules that have radioactive waste in them? Is the waste material radioactive? That's what I'm asking.
Yes, and then the reason why they like make a capsule, it's like they can the radioactive materials cannot be exposed.
Right.
Yeah, in capsule, but we didn't see that product yet, and then there's no
And there's no material on it.
yeah.
Got it.
But they said that like they are inventing that product, so in 5 years we can see if it works. So because actually I want to add one more thing, that nuclear power plant is a huge scale, and then for building one nuclear power plant it takes about 10 years. And then one nuclear power plant can supply a lot of electricity. Like a big city, one nuclear power plant can supply the few big cities. But it's not suitable for like small town or small island. In that area, it's really inefficient to build nuclear power plant. So for that reason, it can be really useful. Okay. And next one is 100% efficient nuclear reactor. We call it traveling wave nuclear reactor. It means that they use another way to generate electricity. But they use nuclear reaction, but they use another way, that traveling wave. So it's a really complicating part, so I will skip that. Then it is made by TerraPower company in the USA. And then they said that it would be really safe, extremely safe, and then there's no waste. Because as I said that it's 100% efficient, and then they use the reprocessing technique. And they don't like even minimize that material, and they use the whole material in nuclear reaction. So I said that uranium and plutonium are the sources of nuclear reaction, and usually we only can use like them amount of sources, but they said they can use the whole sources in nuclear reaction, and it can be commercialized in 2020. And there's an interesting thing. You know that Bill Gates? Yeah, Bill Gates. Bill Gates is the most, he's the investor of that nuclear reactor. And he's really interested in that technology. Yes. So, okay. Next one is nuclear fusion energy. Yes, I talked about the nuclear fusion in lecture 1. Fusion means, I said that two different atoms combined into one atom. then it can make huge energy. And it's really efficient, and then it's extremely safe and eco-friendly, and they don't have to use uranium or plutonium. The source of that reaction is water. Water. We can say that we have infinite source. But the problem is it's not well developed yet, so we cannot use that technology now. But if we can use it, I can say that it can be the main source, main energy source in our life. Because before that, I'll talk about why it's really difficult to use it, because the nuclear fusion can happen in a special circumstance. The circumstance should be high temperature, super high temperature, and super high pressure, like that. Dennis said in his lecture, like should be. Yes, that, and it's really it's quite impossible to make that circumstance, because that circumstance should be hotter than sun. But if it's possible, yes, if it's possible, yeah, that nuclear fusion energy is extremely the best way.
I have a question.
Yeah.
You said no uranium and plutonium.
Yes.
Instead of that, you were using water.
Yes.
And what is different between water resources and nuclear?
Hydro.
Yeah.
Actually, you know, the hydropower plant they use that physically.
Oh yeah, yeah.
Physically they use it, but I mean that water they use it chemically.
So
Electrolysis. Do you know electrolysis?
Electrolysis.
Electrolysis.
Okay.
Kind of it's a water, and then like make it like
Oh,
something. I cannot remember that.
water.
Chemically, yes.
Water.
And then I can say the main source is actually that hydrogen.
In terms of nuclear fusion.
Yes.
That is boiling water.
Not boiling water, like with electricity, we can split that molecule. Looks so easy to make it, but it's really extremely difficult to make it. And any other question? Okay. So far we talked about I talked about how nuclear energy is how dangerous nuclear energy is, and what can be the future nuclear energy. So, what's your opinion about that? Regarding efficiency and safety, I talked about the efficiency in lecture 1, and we can obviously see that nuclear energy is extremely efficient, more efficient than other energy sources. But in safety, we know that we saw several accidents. And then, if you think that we have to develop nuclear energy, what can be the right direction? What thing we should consider? So I will group you guys into three together and three together and three together. And the point is, you should have one strong opinion, group opinion. We should develop it or not.
Develop the nuclear energy.
Yes. Because main problem is nowadays many people try to just get rid of the whole nuclear power plants. than nuclear energy. So let's talk about it.
What's your opinion?
My major? Electronic engineering. Not related.
My major is physics. One of my subjects is nuclear energy and detecting.
Really?
So
You were asking me. You can teach me.
So in our group, we had to talk about what someone was talking about. Which is right. Should we develop nuclear power
Do you think
or not develop nuclear
How was
power?
this lecture, this information?
Reason.
confused.
I think it is too dangerous.
You think it's too
Because
dangerous?
you have to
I
think
think
about that,
we
like
need
in the
more
future we don't have fossil fuels, and then if we don't have that nuclear power plant, we have to pay a lot of money
He's
to
saying
I know.
there are
use
other
electricity.
I know
options.
Because
almost
other
things,
energy
There are
sources
so
are
I can understand.
quite more expensive.
What do you think?
Maybe if I'm first time, maybe I'm.
not maintaining or
I mean, like
Too light
maintaining.
develop the nuclear energy.
No, actually,
Yeah,
what I
know,
want
it
to
takes
tell
one, maybe
you about
later
that
on
is,
should
uh,
talk a lot more
not
than
making
this.
like how can I say? We have to
Okay.
use the nuclear power plant or nuclear power.
You just briefly you
Really
know that
really
much
extremely
before.
clear
Use might be like
Yes,
the one
use
more
or not.
than more about
Because our trend is like to get rid of the whole power plants.
No
Or
waste.
many people just said that.
That one will
We
we
should,
haven't
yeah.
not
remove
completed
that.
yet. Won't be ready until
Yeah,
2020. So we still have to have power between now and 2020. And even if it's introduced in 2020,
Economically,
how long will it
or
take to go
scientifically, or socially.
not.
Really dangerous.
So is there some way then, maybe of combining and like developing non-nuclear
Yeah.
power sources,
So,
and at the same time somehow maintaining but decreasing as other technologies come
If
on?
the happen
available.
accident, we can't control, so
So
it takes so many
we
time
cannot
for resolve problems. So I think
So
we don't need to
in our opinion,
develop anymore.
should we be
or
developing?
why don't you think about the like
Should
that,
we be developing
like,
what kind?
let's say that
okay, what kind of non-nuclear? I mean, yes, you want nuclear. Can you convince us why we
but
should have
like
nuclear?
for example,
yeah, such
the
as
latest one,
like
Because if
there's
you
a
can
different
convince
energy.
us,
water using water.
if you can
Yeah,
convince
it's,
me,
like green energy.
you can't convince me.
Let's say like risk is
In that case,
That-
are you changing your mind?
Then
If
it's
we
extremely
should be developing other forms of
just no risk.
power?
The efficiency is
Yeah, you should
in that case.
heavy hydrogen, maybe using heavy hydrogen.
I mean that many people just try to
Lots of energy. People
make it
fusion.
increase.
So he was talking about wind
But
energy,
how
solar
about like
energy,
trying to decreasing
water energy.
decrease the risk? I mean
What
that
type
development
do you
is
think
like
from his
decrease the
lecture?
risk.
What type should we be focusing on?
Atom has their
The
own
same
energy.
situation and this same situation.
Solar energy.
I can't say.
Solar energy, does it work all over the
Example
world?
is the same
Is solar
situation
energy
as
collectible?
what is explained
Is it collectible all
about
over the world?
nuclear.
That figure?
Yeah.
Actually, it's not a that. Actually, I just put it. I assume that situation,
Combine
but
each other.
We can
yes.
combine it with other resources.
Very difficult.
Okay.
like
I
generally,
think it's important to think maybe that
there is no answer yet. Your
maybe
opinion is the
someone take
answer.
that
Oh, Earth heat,
that
thermal,
principle
thermal
of this
heat,
project.
thermal
So
solar,
that also
under the ground.
Yeah.
thing is,
I agree.
No, I
I
can't.
agree.
Just
We do that in
what
Iceland.
he
There's a country called
says,
Iceland.
nuclear
Did you
fission.
know that? All of
They
Iceland,
divided
the whole
each other.
country, is built on
Yeah.
top
It is.
of a volcano.
Nuclear.
The whole country
Yeah,
is on a
yeah.
volcano. And every house,
Yes, I know that.
all the cities,
yeah.
all the buildings
Nuclear waste
have
less
pipes
than
that go
fission.
down
But
into the
it's
earth.
not
to where the lava level is.
Why?
And collect steam.
Yeah,
steam
it is
comes
about
off the pipes.
future,
And
so
heats
we
the
can't
houses.
imagine. We don't know
But right
exactly.
now,
But
they use it.
can use it.
Yeah, they don't use any nuclear power in Iceland. They use only
Yeah.
thermal power.
Or how about let's think about that like that. In the future, like
Yeah, he said
Nuclear.
nowadays we
So-
rely on
so maybe-
without nuclear energy,
What
you don't have to worry about
in
any
South
waste
Korea,
from
every
the
area
power
has
plant.
different
40
special
But you
way
have
to
to a lot of
get
money,
energy.
so
So
you could
in the
even
really
to
hot
pay
countries,
like your electric bill.
would be
Yeah.
good.
So
Yeah.
Yeah, not now.
In the
you cannot
countries,
easily use
Well,
electricity.
right,
better
and
to
in the
try to cut
countries
down
that
the nuclear
Or
energy.
even though
Are on
there's
the
some
ocean,
risk, some
have
risk,
big,
Yeah, that's
Um,
my opinion.
you don't have to
Yeah.
worry about
Waterfalls.
Even though
money,
another
economic,
hydroelectric.
financially.
hydro,
less
because
Which
hydroelectric power
situation
is
like
not
do you
but
prefer?
then it's not.
hydroelectric water
But they
power,
don't have any
right?
risk.
So
So it
maybe
depends on
No,
location.
they have
Yeah.
also
Yeah.
risk. but
maybe that would be an alternative, and maybe
less
there's some way of combining in the future, not now, because we don't know how to do it now.
Yeah.
Maybe there's some way of converting all of that energy,
Develop it.
the excess energy,
Just
to
maintain.
be banked
Possible to
somewhere.
cut down the nuclear energy.
and
Yeah.
then sold to countries that don't have resources.
biomass,
Safe, yeah, safer.
Yeah.
In that
high
case,
energy.
Yeah.
or
Like you mean that make it
Maybe,
a lot?
maybe. So not the fossil
Because
fuels,
it means that
Yeah.
not
risk
the
is
fossil
getting
fuels
bigger.
like gas and oil,
Yeah.
not that, because it's
yeah,
highly,
or hydrogen.
it's
Yeah, it's a
highly
good idea.
polluting. Yeah.
Why don't you
Last of it.
share your
Can't save energy. You know, if we make
sorry
some
for
energy to nuclear
you guys
energy,
in trouble.
Well,
after
every
we
country
can't
will
save
have its own
Oh.
resources and will create its own
I
heat,
think
its
in
own
lecture one
energy.
he said
But maybe there should
Okay,
be
we
a
have
separate
1 minute left.
times
officially
when
we have
one
4
country
million.
needs
You have to
more.
yeah, I forgot to say that you have to
nuclear energy.
present your opinion.
So who's going to present and it's not
You
going
hear
to be
me?
me?
Individual or only one amount of nuclear
Sorry, I can't explain that.
One person can do that, or you can separate your speeches.
I can't present it because I'm one of
we
the
can
judges.
use that for
So I can't
100
present.
years. But after
It will
that,
have to be
we
one
can
of you.
use
Or maybe both of you together.
already used it. It's not
Okay, while you're speaking, yeah, you can help
So
him.
anyway,
Like you
we
can add some
should
more.
develop
Okay, so tell me
some
what you will say.
energy that
Oh.
can be limited.
Number one,
The
are we in
solar
favor of
energy
nuclear power
is
or
not-
against developing
We're against developing.
She said that. Like
nuclear?
developing in a good, like a to minimize the safety, but expand it. Yeah, we shouldn't expand it or
Naturally,
a lot.
like a wind.
Build more.
Thermal.
That's right.
Thermal.
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 Under the earth.
Okay.
Thermal.
Okay.
Yeah.
Finish.
Yeah, but keep going.
Okay. Okay.
Yeah. So
Okay. Let's divide pros and cons. Yeah, which group is on pros?
Pros for
Pros for like developing nuclear power plant.
oh my god.
Nobody. So the every group doesn't like it. Yes. So yeah, how about this group? What's your opinion?
We prefer developing another energy than nuclear energy because, as you said in lecture 1, nuclear energy is limited resources, right?
No.
No, you said.
You didn't pay attention, my
Actually, we have 4 million resources.
But we can use it for more than many thousand years.
But anyway, it is not unlimited.
Thousands of years? Yeah, okay, yeah, keep going.
Okay, so anyway, so we should focus on unlimited energy like solar energy because it's less risky. and yeah, that's how.
Okay. Anything else?
Some more, because we know nuclear energy is so efficient, but like it has so huge damage. So it's better to try to cut down that energy and develop another energy to replace that nuclear energy to solar or hydrogen energy. Then.
You mean cut down the energy means our consumption, energy consumption?
No, using nuclear energy because
using it,
over
yes.
30% of
Yes.
energy we use in South Korea.
Yes.
That's why we are so reliable to that. That's why we cannot say, oh, let's get rid of nuclear energy, but we can try to cut down that usage and then develop others.
Yeah, good. Yeah, I think like that actually, yeah, risk is the risk. And then now we rely on the nuclear energy so much. So even though we don't have the perfect solution of that safety, so this group thinks that we should cut down that nuclear power plant. And how about this group?
Oh my god.
Yeah. I think nowadays degree of development about the nuclear is very enough. I think because we have already many experience to some accidents like Fukushima.
Yes.
So we don't need to develop anymore because personally we have to find another resource from natural sources. So I think many scientists are finding the new something, but we have to avoid the dangerous thing because we have to pass the very safety or the earth to offspring.
Yeah. Yeah, this group's opinion is good. Is that suddenly I forgot. Sorry. Yeah. They said that we'd better kind of invest other methods or other ways to kind of other natural resources or developing other methods would be better than developing the nuclear power plant. Yeah, that's what you're.
That's
what
my
you said.
point.
Yes. Okay. Yeah. Good. How about this group?
Yeah, we think we should develop another source like a natural source, wind or thermal. We talk about thermal. It's for example, Iceland use thermal energy.
Yes.
Yeah, everywhere.
Yes.
So we can to develop this energy or the another country is like how can I say hot country. They can use solar energy.
Yes.
So depends on
the location and environmental condition.
Yeah.
They can choose the suitable ways.
Yeah.
Yes, this is a good idea.
Yeah.
Actually, in the USA, they use a lot of solar power. So, because they have a good environmental condition. But in case of like in South Korea, actually, there's not the best one, the best method. But we can find it. Yes. Yeah. So anyway, we should kind of cut down the nuclear power plant, and we shouldn't invest like that nuclear power plant. You mean? Yes. Okay. Good. Okay. Oh, I didn't know that many people being like that. So, okay. I think this discussion, your opinions can show show your opinions show that our nowadays trend of the nuclear power plants. Actually, there's no one who support that nuclear power plant, and I think like that. But in my opinion, as a conclusion, I don't like advocate the nuclear energy. But as far as we know, we rely on the nuclear energy so much, and now, unfortunately, we don't have any other alternative way to make up for that much energy. So it's impossible to get rid of the whole nuclear power plants at the same time. But anyway, we should consider the safety more than efficiency. Okay, so that's my conclusion, and thank you for coming today. And yeah, thank you.